human, did you know that snowflakes are tiny kingdoms of ice crystals and they could be a clue to galaxy formation? But first, is every snowflake truly unique? Well, the jury is out in the sense that it is impossible to round up trillions and trillions of snowflakes and identify a true doppelganger. That's just too much data pork for one fork. But on a molecular level, the idea that each snowflake, as defined by a single vapor-grown ice crystal, is wholly unique is very possible, and this is according to Hans Rowland, Associate Professor of Meteorology at Penn State University, who says, let's pretend like he sounds like Owl from Winnie the Pooh. I would say with a great deal of confidence that all crystals are different on a molecular level purely because there are differences in the atomic structures of the atoms making up a water molecule and hence in the water molecules themselves. But visually, there are only so many shapes a snowflake can take. So in that sense, you have a finite number of snowflake types. 35, in fact, depending on the snowflake expert you're talking to. And how these delicate ice confections take shape all depends on the conditions in the cloud in which it was formed. The temperature has to be at or below 32 degrees Fahrenheit, and you have to have a speck of dust that pairs up with water vapor and crystallizes into ice. Once it does this, a prism forms with the most common configuration of 6 faces and a top and a bottom. Now, a cavity forms in each prism face where ice grows fastest, and then 6 branches sprout out forming a hexagon. Now, whether or not it becomes larger and more ornate in a hexagonal structure depends on that temperature in the cloud, not to mention the descent to the ground. The snowflakes that most resemble elaborate doilies come from colder conditions found in high altitude cirrus clouds. So why gaze lovingly into a microscope at these ice crystal kingdoms? Because they're a window into the infinite universe. In a paper published in the monthly notices of the Royal Astronomical Society, Professor Duncan Forbes says that, like snowflakes, galaxies need a little seed to get started. For galaxies, this seed consists of an inner region of stars that are formed from collapsing gas. And just like snowflakes grow as water vapor accumulates on the surface, a galaxy collects more stars as part of its growth in a process called accretion. So think of these tiny crystal galaxies the next time you are trudging through a snowdrift or catching a lone snowflake on your mitten. Hey, have you guys seen those amazing photos of snowflakes that were taken with an electron microscope? Well, if you haven't, you are in luck. Check out stufftoblowyourmind.com to see these images. Also, to keep the videos coming, make sure to subscribe.